Okay, team. So now we're on part 3. On this one, we're going to focus on drawing. So far we've gone from... I'm hear that flat Australian accent on the drawing. So in the previous ones, we've gone from uh, naming ones that we've seen, and now we're going from the name of an alkene. And again, we're all alkenes at the moment. We're going from the name to being able to draw it. So I'm going to draw it in 2 different formats, and I'm going to highlight 2 different aspects. One thing that we do differently to how this is written down, just because I never get to use the rainbow pen. We do it... Whoa, that's gross. Note to self, don't use rainbow pen. So we do it a little differently, and it doesn't make any difference at all. I think the way we do it looks gross. It's gross to say it, but it works really well as a learning tool. So here we have written 2-ethyl 1-pentene. I know exactly what that means, and you probably know exactly what that means, and maybe you don't. Because the way we've been writing this would be 2-ethyl pent 1-ene. And the reason we do that is to allow us to indicate very clearly, to minimize any mistakes on where that pentene might be. Sorry, that double bond. The other thing that we're going to show you is you've seen compressed structural formulas, which are fun. They look like, not expanded structural formulas. They look like this. Cool. So that's a fine way to draw it. It takes a bit more effort. And that's how you'll have to draw it in things like exams and such. However, we, as a chemist, the way I would draw that is not like that at all. I think that's a bit of a punish. I would use something called a skeletal formula. And I'm going to draw all of our answers in both skeletal formula and expanded formula. So skeletal formula looks like this. Isn't that pretty? I love it. So organic chemistry is what I used to work in before I was a teacher. The genetic side of organic chemistry, but that's what it was. Anyway, so I like these. Now, what we have here is each point represents a carbon. Okay, so this is a 3-carbon. This is propene, and this is propene. We don't need to number propene because propene can only ever be 1 propene, because if we, lowest possible thing. So there's propene in 2 different forms. What's different is one, the skeletal form has a bit more of the sort of the shape that it would have. Like, they're not straight lines like they do have a bit of a kink to them. But it's ignored off all the hydrogens, and that makes life a little bit easier because we know they're there, right? Like, aside from any bonds that the carbons have, we also have extra stuff as well. Like, we also have, it fills up with hydrogens. Okay, so that's the 2 different ways we're going to draw it. Now, let's break down what we have here. We have an ethyl group and a pentene. Now, obviously, we're going to draw the pentene first. There's 5 carbons. There's a double bond there because it's a 1. You can number all the way. Then we have an ethyl group on the second. You can go up or down. It doesn't really matter. I mean, it's not wrong. Now, without thinking, I've actually made an error. You see, I've got a hydrogen there and a hydrogen there. Let's count how many bonds this carbon number 1 has. There's 1, 2, 3, 4, 5. Because it's got the double bond there. And that's too many. So we get rid of this one, and it looks like that. Now we have, see how many bonds we have around the other one. 3, 4, 5. That's too many. So remember, we use the hydrogens to fill up the bond spaces. So let's get rid of this hydrogen down here. We'll need that one back. And that's how that's done. Nice and simple. Now let's draw it in the So we've got our double bonds. There's our pentene backbone. So we'll just use this orange pen just to show how we're going. So we have 5 carbons along. We have a double bond at the first carbon here, which is nice. And our ethyl group is along there. There's our 2 carbons off that. And that's it with this skeletal structure. So yeah. All right, now let's move on to dimethyl butene. There's only a few. So we start with the butene. Nice. Then we go to the dimethyl. So it's got 2 methyl groups. And there are 2. And all right, I want to point out a couple of things. First off, you'll notice that these hydrogens here are spread in a slightly different way. That's because as they perk out the back, they have a relatively positive charge. So they're going to try and fill up the space as best they can. And there's all sorts of Vesper theory reasons for that. Then you'll notice that first off, we've been very careful this time about how many bonds everything has. And you'll notice that this one comes up over here, whereas this one is on the other side. And the reason it's on the other side is because that's actually just the way it would space out. It spaces out so as to give you, or to give the particles more freedom. So that, again, all those opposing forces aren't stacked in together. It can sort of twist around those bonds. So let's see how this would look as a skeletal form. Spoilers, pretty. There's our butene backbone. And there's our 2 diethyl groups. It turns out I can't read. That actually says dimethyl and not diethyl. So you get a bonus one. So that's what the ethyls would look like. Let's see what the dimethyls would look like. I'm not going to label these. I'm just going to draw them. So I'm not going to talk over these ones. I'll just draw these ones quickly. Obviously, still pretty. Then, so that's our dimethyl butene, and I'll still number it. We'll still see that we've got the same corresponding methyls, and it all works. Okay, let's look at trimethyl 1-hexene. 2, 3, 4, trimethyl 1-hexene. So, hexene. Let's draw that straight down the middle. Hex 1-ene, so the double bond is first. Right, now we look where our methyls go. We've got 1 at the 2. All right, sweet as. So our trimethyl, which means we have 3 methyl groups, 1 there, 1 there, and 1 there, and they're numbered accordingly. So, skeletal structure. So we put our 1, so there's our 6. Now, obviously the numbering is for us and our working out. Now let's put in our ene. You'll note that it goes on the inside. It doesn't go on the outside. It'll do that when it's an ine, but it doesn't need to do that now. And we put them in the right spots. So you'll notice they alternate. Oh, here's another thing. Another thing I like about the skeletal ones is it's just one less place to make a mistake and still show your understanding. Yeah, so that's those. I'm going to do this last one. 3-hexene. So 2, 3, 4 trimethyl 3-hexene, or 2, 3, 4 trimethyl hex 3-ene. I'm going to do this one without talking about it. I just want you to see if you can follow along. So there is our trimethyl 2, 3, 4 trimethyl 3-hexene. Now let's do it as the skeletal formula. Okay, it's on this side. And there we go. That's it in both forms. Okay, so we'll wrap this one up now, and we'll hit part 4 of this monster worksheet. So, this worksheet, if we weren't talking through every single step, would probably take you 20 minutes, maybe? I don't know. I'm a teacher. It's quicker for me. So part 4 next.